Hi, welcome back. I've been noticing that I've been going a little bit over time actually on these videos, so I'm going to try to keep this one a little bit shorter. So, in the last video lesson we talked about truth-functional entailment, and we said that a set of sentences, which we're already familiar with, right, different kinds of sets of sentences, because we've already had to look at when a set of sentences is consistent, for example. So what we did was we specified, or we gave the definition for truth-functional entailment in terms of when a set of sentences entails another sentence, and we showed that that holds if on every truth value assignment that you assign for members of the set, in other words, the sentences in the set, whenever they're true, so on every truth value assignment where those sentences are true, B has to be true as well. And as long as B is always true whenever the set of sentences are true, then we say that B is truth-functionally entailed by that set of sentences. And if there's ever a scenario where B is false when the other two sentences in this case are true, then we say that that sentence is not truth-functionally entailed by the set. So here we had an instance where there's a truth value assignment, namely this row, where A is true and B or C is true, but B itself turns out to be false. So then we know that B is not truth-functionally entailed by the set gamma, where gamma is the set of sentences. And we have a symbol for how to express both truth-functional entailment, which is up here. So this means that gamma truth-functionally entails B, and here we have it that gamma does not truth-functionally entail B. Okay, so now we're going to give this notion of, or now we're going to give a notion of validity. And this is the thing that we've been working up to this whole time. And it's actually relatively easy compared to everything else. So recall that an argument of SL has two or more sentences, and one of those sentences we call the conclusion, and the other sentences we call the premises. So before, we could think of this as an English argument, but here we're giving a definition of what an argument is in SL. And so here's an example of an argument in SL. Premise 1, remember, so here P1 is short for premise 1, is A. Premise 2 is if A, then B. And although I'm saying, if then in English, in SL, we don't have a notion of if then. What we have is the material conditional. So the second premise is, if we're going to read it in terms of the symbols of SL, we would say A, material conditional, B. But that's the difficult way of talking. So we're just going to say A, if then B. Where in our English, we're just saying that that's sort of a lazy way of saying what the symbol in SL is. And then our conclusion might be B, for example. So this is an argument in SL. We just pick one of the sentences, in this case B, to be our conclusion, and then we have some other sentences that we take to be our premises. And just as, I guess, a little bit of comments on notation, it won't actually matter the order of the premises. I could have just as easily swapped P1 and P2 and reordered them according to different numbers. And it doesn't matter, right? So A might have been P2, and if A then B might have been P1. That won't actually matter. All that matters is that one of those sentences has to be designated as the conclusion. And if you recall now, informally we said that an argument is valid if and only if whenever the premises are true, the conclusion must be true as well. So we said, think of the scenarios where that make the premises true. In those scenarios, does the conclusion have to be true as well? And so we're using this sort of intuitive notion of scenarios or cases or possibilities. Here we're going to have a very rigorous way of talking about what exactly it is we mean by these cases or these scenarios. And not in the sense that we're going to be detailed about how to build them. all we're going to say is whether or not the sentences are true or false. So we're going to be talking about truth value assignments instead of scenarios or whatever our looser way of talking was. So we can give our definition then of validity in terms of truth values. And so here it is. An argument of SL is truth functionally valid if and only if there is no truth value assignment on which all the premises are true and the conclusion is false. So this should sound very similar to what we've already seen in terms of truth functional entailment, right? What we saw with truth functional entailment, if we go back and we compare it, we said that there's a set of sentences that truth functionally entail another sentence if and only if there's no truth value assignment on which every member of gamma is true and P is false. And we have this almost the same for validity. Here what we're saying is an argument of SL is truth functionally valid if and only if there's no truth value assignment on which all the premises are true and the conclusion is false. So in other words, we can think about the conclusion being like the conclusion being like the sentence that is entailed by the set, where the set of sentences in this case are the premises. So there is a subtle difference here, right, between a set entailing a sentence and what we're here counting as a truth functionally valid argument. So they are subtly different, but hopefully you see the connection between the two. So let's go over an example then of an argument that is truth functionally valid. So we'll consider this argument here of SL, and we're going to build a truth table to test to see whether or not this argument is valid. And okay, so let's do that. So we first need to have, we need to incorporate these sentences into our truth table. So we build a truth table as we usually do. So we have A, and then we have our next sentence, if A, then B, and then we have our conclusion, B, which we'll keep all the way here to the right. And again, by convention, the conclusion or the sentence that is entailed by the other sentences is by convention put all the way on the right. Okay, and then we fill out our truth table as we usually do. So in this case, this is a conditional, and we know that the conditional is true, or the only time the conditional is false. This is hopefully maybe the better way of doing it. Whatever trick you've used to memorize this, that's the one you should use. But the one I generally tend to use is the only time I should ever write false for material conditional is when the antecedent is true and the consequent is false. And that's in this row. And all the other scenarios, oh, I actually didn't copy that right. This should be, A should be false here, and A should also be false down there. Okay, that's much better. So whenever the antecedent is false, we know right away the whole thing comes out true. The only time the antecedent, or the only time the conditional is false is when the antecedent is true and the conditional is false, which we have right here. So now what we have to do to check for the validity, to check whether or not this argument is valid, is to look at the truth value assignments. In other words, we should look at all the rows where the premises are true. So that means this row right here, that means this row right here, that means this row right here, right? We don't need to look at this row because one of the premises, namely if A then B, is false, so we can ignore that case. So what we do is we look at those rows and we check to make sure that our definition is met. So we say an argument is truth function valid if and only if there's no truth value assignment on which all the premises are true and the conclusion is false. So let's do that. So here we know that both the actually, I just realized I made another mistake. Dang it. This last row should also be false. And it should also be false here. Sorry, I copy and pasted this, and oh wait, no, that's not right. Sorry, that one should be true, and this one should be false. There we go. Whew, okay, much better. So, so what I said before was actually not correct. Sorry, guys. We don't need to look at this row because A on this row is false. And we don't need to look at this last row because, again, A is actually false. So we don't even need to check the last two rows. And we also don't need to check this middle row either because here, this premise, if A then B, is false. So the only row, in other words, the only truth value assignment that we actually have to check is this very first one up here. Because that's the only, it's only under this truth value assignment where the premises are true. And now what we have to do is make sure that the conclusion is true as well. As long as the conclusion is true, then the argument will be truth functionally valid. And indeed, that is the case, right? B is true here. So here we say, there is no truth value assignment in which all the premises are true and the conclusion is false. Another way you could say that in your head is, look, I'm going to look at all the cases where the premises are true. As long as on all those cases the conclusion is true as well, then the argument is truth functionally valid. But if I ever find a row where the premises are true and the conclusion is false, then I know that the argument is not truth functionally valid. Okay, so that covers both truth functional entailment and truth functional validity. If there's any other questions, make sure to bring them up in class. And just as a little side note here, sometimes you'll see this double turnstile symbol in front of a sentence like P. And all that is short for is the empty set. And one of the things that we'll be able to discuss later on is that you can actually have the empty set, right? So it's just a set of sentences where there are no sentences, but you still get this empty set, right? The empty collection can actually still truth functionally entail certain kinds of sentences. And we'll talk about that in a little bit more detail later on.